Most automations don't break because the tools are bad. They break because the way we design them is fragile. They work for a while, then something changes and things stop working. This video shows a different approach where AI agents help design automations that are planned, reviewed, and reliable instead of quietly failing in the background. And the outcome is simple. By the end, you'll be able to explain this model clearly and you'll know what to look for to validate it. Not in theory, but by inspecting what the system produces before it's allowed to run. If you've built automations for a service business, you've probably felt this pattern before. At the beginning, everything feels clean and efficient. Form comes in, a record gets created, a notification goes out. On the surface, it looks solid. Then time passes. A client submits something unexpected. A required field gets added. A teammate makes a small manual adjustment to the process, and the automation keeps running. But it's no longer doing exactly what you think it's doing. That's the uncomfortable part. Most automation failures don't announce themselves. They don't crash loudly or throw obvious errors. They produce incomplete records, incorrect updates, or missteps. You only notice after something downstream breaks, or worse, after a client or team member points it out. By that point, the damage is already done. And in services, the damage rarely looks dramatic. It looks like someone didn't get onboarded properly. It looks like the wrong person gets notified or nobody gets notified at all. It looks like a duplicate gets created, and now your team is split across 2 threads and 2 tickets. And no one's sure which one is real. After that happens a few times, your behavior changes. You stop trusting the automation layer. You start checking records manually. You keep a mental note to verify one step. You add manual backups just in case. And now the system that was supposed to reduce cognitive load becomes another thing you have to monitor. That's when people say automation doesn't work for their business. But the issue isn't automation itself, and it's usually not the tool. The deeper problem is how automation is designed. When you build automations today, most of the intelligence lives in your head. You're deciding what matters, what should happen, what should never happen, and what edge cases might come up. Then you translate all of the thinking directly into triggers and actions. Once it's built, that intelligence is frozen. The automation doesn't know why it exists. It only knows what it was told to do at that moment in time. When the business changes, the automation doesn't adapt, it just keeps running. So instead of asking how to build better automations, a more useful question is how to design automations in a way that makes failure visible and preventable. That's where an agent-led approach comes in. Not an agent that runs everything on its own, but an agent that helps with the hardest part of automation, which is thinking through the workflow before anything executes. At a high level, this changes what the system produces. Instead of jumping straight from an idea to a live automation, the agent produces things you can inspect: a plan, a draft workflow, a validation report, and then it routes that package for approval. The automation doesn't just run because a trigger fires. It only runs after the design has been reviewed and approved. That single shift changes how reliable the system is. This is where proof starts to matter. Anyone can say AI will make automation smarter. That's not useful. What matters is that you can see the plan, see the draft, see the checks, and see the approval gate. Those artifacts are what make the approach believable. Everything in this model is built around one simple spine: plan, draft, approve, execute. Planning is where intent and constraints are clarified. Drafting is where that plan becomes a concrete workflow. Approval is where a human confirms that the design matches reality. Execution only happens after all 3 are complete. This isn't about slowing things down, it's about removing guesswork. In the planning step, the agent takes a plain language operational goal and turns it into structure. Not code, structure. What eventually actually starts the workflow. What data must exist at the moment the workflow starts. What records should be created or updated. What should never happen. What edge cases are likely. This is the step most automations skip today or handle informally, which is why so many problems show up later. And notice what the planning is doing. It's pulling the intelligence out of your head and putting it somewhere you can review. Because right now, when you're building an automation at midnight, you make a bunch of assumptions. You assume the project name will always be formatted correctly. You assume the form will always include a phone number. You assume the client won't submit twice. Those assumptions are the hidden source of fragility. Drafting is where that plan becomes explicit. The steps are listed in order. The data mappings are visible. The conditions are stated clearly. If something depends on something else, it's named. Importantly, this draft is still not live. It's a proposal. That distinction matters. A proposal can be wrong safely. A live automation cannot. Approval is the human in the loop moment that makes the whole system trustworthy. You're not approving every individual run, you're approving the logic that governs them. Once the design is approved, the system can execute repeatedly without supervision, because you've already seen how it behaves on paper. Execution comes last, and it's intentionally boring. The automation runs because it was designed, validated, and approved. If something unexpected happens, it doesn't quietly improvise, it surfaces the issue instead of guessing. To avoid unrealistic expectations, it's important to be clear about boundaries. The agent isn't running your business, it isn't making strategic decisions, it isn't guessing intent. Its role is to translate clearly stated goals and constraints into inspectable designs. Humans still define outcomes, humans still approve designs. The agent handles consistency and completeness, not authority. So if you're skeptical, that's healthy. You should be skeptical. The promise here isn't automation on autopilot. The promise is automation that earns trust because it's designed like a system, not a pile of actions. Now, let's walk through the proof end to end using a simple service workflow. A client submits an intake form. You want a project created with specific fields filled in. You want the right team notified. You want to prevent duplicate records. That's the operational goal. Along with that goal, you provide a small amount of context. Which fields are required for a project to be considered valid? Which records are allowed to be created or updated? What must not happen, like creating duplicates or notifying the wrong person, and what success looks like, meaning what should be true in your system after the workflow runs. You also give the system one realistic example of the trigger payload. Not because the system can't function without it, but because real workflows are shaped by real data. You want to validate the plan and draft match the actual shape of what comes in. From there, the agent produces a plan. It defines the trigger in plain terms, it identifies the required data, it sequences the steps, it calls out dependencies, and it lists edge cases that would change behavior. For example, it should be able to state in a way you can read what happens if a client submits twice. Does the workflow update the existing record or create a second one? What happens if a required field is missing? Does it block and flag it? Or does it create an incomplete project? What happens if a project already exists under a different identifier? What happens if the destination record can't be created for some reason? All of that should be visible in the plan before anything runs. Then the agent generates a draft workflow based on that plan. The systems are concrete. Check for an existing record using a defined key. If it exists, follow the update path. If it doesn't, follow the create path. Map the required fields explicitly, applying branching conditions where the plan required it, notify the right roles, record what happened. And here's the belief point. Alongside that draft, the agent generates a validation report. It doesn't just say, looks good, it lists what was checked. Are all required fields present in the incoming payload? If not, which ones are missing? Are all required fields mapped to the destination record? If not, where is the gap? Is there a defined strategy for duplicates and rerun safety? In other words, can this safely run twice without creating a mess? Are there any unsafe actions like updating something without a clear identifier? If anything is unclear, it becomes a blocker. The draft is marked as executable, nothing runs. The system doesn't guess, it stops and waits for clarification through the approval process. That's the reliability feature. This is also where most manual automations quietly fail. In a manual build, you might leave one mapping half finished. You might forget to handle the duplicate case. You might assume a field is always present. The automation will still run, it will just run wrong. In this model, the design is not allowed to move into execution ready status until those holes are surfaced and resolved. When the plan, draft and validation report are presented together, this is usually the moment where things click. Instead of staring at a chain of triggers and actions and trying to infer intent, you're looking at a structured design that matches how you actually think about your business. You approve the design, and only then does the system become executable. The state change matters. Before approval, the system is visibly blocked. After approval, it's visibly ready. There's no ambiguity about whether something should run, and there's no illusion that it's safe if it hasn't been validated. Now, to keep this practical, it's worth calling out the minimum viable version of this approach. You don't need a complex architecture to get value. At a minimum, you need a planning artifact you can read, a draft workflow you can inspect, and an approval gate that blocks execution until you're satisfied. Even that alone reduces silent failure dramatically, because once you have that, you've already changed the failure mode. Instead of it ran wrong and we find out later, you get it can't run yet because something important is unclear. That's a healthier failure mode. It's earlier, it's visible, and it's correctable. The validation layer is where most skepticism tends to show up. People worry about automations doing the wrong thing. That concern is valid. The answer isn't less automation, it's better guardrails. Validation checks don't need to be fancy. They need to be consistent and strict. Required fields present. Mappings defined. Duplicate risk addressed. Unsafe actions flagged. Unknowns surfaced. And the key principle is that uncertainty is not treated as something to guess, it's treated as something to block. If validation fails, the output is clear. Draft not executable. Here's why. Nothing runs in the background. Nothing half works. That's what makes the system trustworthy. It's careful instead of confident. The approval layer reinforces that trust. You're approving the design once, not babysitting every execution. And you're approving something concrete. A plan, a draft, a list of checks, not vibes. This also answers a common concern, which is that human review sounds like added work. In practice, reviewing a draft is usually much faster than designing from scratch. You're not deciding everything from a blank page. You're confirming and correcting a proposed design. That's a different kind of effort, and it scales better. Observability is the final piece. When something does break, you don't want mystery. You want visibility. So the system should be able to show you what ran, what didn't, and why. If a run is blocked, it should tell you which validation check blocked it. If a run executed but didn't complete, it should show which step failed. And if a run took an alternate branch, it should be clear what condition caused that branch. This isn't about fancy dashboards, it's about designing systems that explain themselves. Because the only thing worse than automation failing is an automation failing and nobody knowing what happened. There are predictable mistakes people make when they try to apply AI to automation. One is skipping planning and going straight to execution. That just creates faster failures because the same missing assumptions are still missing. Another is removing human approval entirely. That turns the system into something you can't trust because now the agent is not only drafting but also authorizing. And if you're running a service business, authorization matters. Another is treating validation as optional. That brings back the original problem. If drafts can execute without strict checks, you're back to a system that looks fine until it doesn't. These approaches fail for the same reason manual automations fail. They assume too much. Let's recap what actually changed here. The original problem wasn't that automation tools are unreliable. It was that the design lived in your head, then got frozen into a workflow that couldn't keep up with change. The shift is moving design into something you can inspect before execution. The core model is plan, then draft, then approve, then execute. And that increases reliability because validation and approval happen before the workflow is allowed to run. So failures become visible and preventable instead of silent and expensive. The point of this model isn't autonomy, it's reliability. It's making design explicit, reviewable, and enforceable. When you see the plan, the draft, the checks, and the approval gate working together, the system stops feeling fragile and starts feeling professional. By now, you should be able to clearly explain this approach to someone else. An AI agent helps plan and draft automations. Humans approve the design. Execution is gated. Validation prevents silent failure. That's the future of workflow design for service operators. Not better tools, better structure. If this way of thinking about automation is useful, keep it in mind the next time something quietly breaks.